In this video, we're going to talk about the do while loop. The do while loop is not the most popular loop, but it does have a special twist to it that makes it really appropriate for certain algorithmic situations. The do while loop is different from the while loop and the for loop because it's a post test loop. Post test loops test the loop condition after the body of the loop executes rather than before it executes, like we've seen with the while loop and the for loop. Post test loops are again convenient in certain situations because the algorithm has to be executed at least one time. And so it's not worth testing to see whether an expression is true or false until the entire loop body has executed. Let's look at the syntax for the do while loop. It starts with the reserved word do, and you can see there's no condition that's tested at the beginning. Then we're going to execute the body of the loop, that's everything in between the curly brackets. Then following the curly brackets, we have the reserved word while with the expression that controls whether or not to repeat the loop body. When the expression is true, we'll repeat the loop body after the first execution. If the loop expression is false, then we'll continue on with the rest of the program. This is seen over in the diagram to the left. You can see that you'll perform any initialization steps that happen up earlier in your program before you encounter the do while loop. Then when you encounter the do portion, you'll immediately start executing the loop body. Once the loop body completes, then you'll evaluate the expression. If the expression is true, then you'll go through and repeat the loop body again. If the expression is false, then you'll continue on with the rest of the program. One of the syntactic nuances of the do while loop is that it ends in this semicolon. And that's different than regular while loops or for loops where we don't include the semicolon. This opening curly bracket would be here. But with a do while loop, you need to have that closing semicolon in order for it to compile and work. Let's look at an example program where we use a do while loop. One situation where do while loops often come in handy is when you're writing a program that has, say, a menu of choices that you want to display to the user. You want to allow the user to pick one of those choices and then execute some algorithm. And then after the choice, you want to evaluate whether or not they want to keep going or stop, and then print the menu again if they want to keep going. And that's exactly what's reflected in this example. In this example, we have a variable called choice that's going to keep track of a user's choice. And they are going to be presented with a menu of options. You can see that right here inside the loop body, where they have cool option number 1, cooler option number 2, and then a third option to quit the program. So you can imagine you might have various choices or operations that you might want to perform in the program. And so you allow the user to select which of those options they want to execute. That's exactly what's going on here with the algorithm. So after we print out this menu of choices, we're going to read in the user selection, that's choice. And then if the user chooses option 1, we'll perform some algorithm. If they choose option 2, we'll perform a different algorithm. And because I just wanted to keep the focus of this example on the loop itself, I didn't put fancy code in here for the various options. You can just imagine that if you had some calculation or other thing that was supposed to happen in your program, you could put that here inside the if body, and then you could put the alternative here inside the else body. And then finally in the program, we have this loop control that says, while the choice is not equal to the value 3. And so I've coded that by using the equals operator to compare the value of the choice and the option number 3. And then if they're not equal, so I have the exclamation point in the front, that's when we want to continue. So let's do a little example here. Suppose that we're running this program and we initially just start at the beginning. So we have this choice variable, and suppose that's initialized to nothing in particular right now. And then we encounter that do statement. And that says do. And so you always just start doing the body of the loop here. And so we're going to print out the menu of choices, option 1, option 2, option 3. And the user will select one of those. So they'll type in either a 1, 2, or 3. And so let's suppose they type in a 2. Then we're going to compare that to the two different options. It matches with the else option, choice is equal to the value 2. So we'd perform that activity, whatever that represents. Now we're going to compare the value of choice to 3. So we're comparing our choice, that's the 2. Is it equal to 3? No. So this choice equals 3 is going to be false. And then when we say not that, that's going to give us the inverse value. It'll be true. So this while condition is true in the case where choice is equal to 2. That means we're going to go back up to the top and do the loop condition again. So at the beginning of the loop, it says do these things. So we're going to print out the menu again and allow the user to enter a new choice. Let's say they enter the value 1. It's going to replace our current value here. And then we'll compare that value to our different choice options. So this time it's equal to 1. We'll perform the cool option, the first choice algorithm. And then we're at the end of the while loop. So we need to evaluate this expression again. We're going to check to see if choice 1 is equal to 3. That's false. And then taking the not of that response, we'll get a true answer. So that means we're going to go back up to the top and repeat the loop again. So we'll print out our menu of choices. Suppose we enter a 3 this time. So our choice is going to get updated. So it's a 3. And then we're going to compare the value 3 to these different if statements. 3 is not equal to 1. So we skip that one. 3 is not equal to 2. So we're going to also skip the else if. So we're not going to do any of these options. Instead, we're at the bottom of the loop. We're going to make our comparison with our loop control. We're going to check to see if 3 is equal to 3. So that's true. And then taking the not of that makes it false. So now our loop condition's false. When the loop condition's false, that's when we want to stop repeating the loop and we're going to continue on with the rest of the program. So you can see that this program successfully determines whether or not to continue executing a menu of choices, and it stops whenever the user has entered that choice that corresponds to quitting the program, not performing either of the algorithms. As we're wrapping up our information about loops, I thought it would be a good idea to talk about some best practices for repetition statements. These are just ideas about how you communicate your algorithm and how you format your code so that it's easy to collaborate with other people and to share your ideas in a way that's easy to understand. So there's a few tips on here. These are all based on national standards, and all of these tips are things that all of the UMW computer science faculty members have agreed to, and so we all think these are good ideas. These are expectations, not just for this course, but also for code that you would write moving forward within the degree. So the first step is about nesting conditional statements and loops. And it says nesting any combination of decision statements and loops should not be more than 4 levels deep. And so that's not saying that you can't write something that's like an if, else if, else if, else if, else if. That's completely fine and not what we're talking about here. What we're talking about is having maybe like a while loop where inside the body of the while loop, you have an if statement, and then inside the body of the if statement, maybe you have a for loop, and then inside the body of the for loop, you have another while loop, and then inside the body of the while loop, you have another while loop. So you can see there's just like a lot of nesting levels here. We're saying don't do that more than 4 times. So the first 4 are fine. After that, it's getting too complicated. First, it'll make your code hard to read in the editor just because of the levels of indentation. And second, it'll just be hard to mentally process like the significance or what are all of these decisions and repetitions. So if you have something really complicated like this, where you have a lot of different levels of decision making and repetition, our recommendation would be to pull out some subset of them and make that a method or a function so that you have that part of the algorithm encapsulated in another chunk of code in your program. And I realize we haven't learned about methods yet, but that is the next topic. We'll be talking about that all next week, and then you'll be all set up to handle those types of situations in your code. The next tip is about the body of the for loop or decision statement. For any of those, you want to make sure that you include the curly brackets for your bodies, even if your body only contains a single statement. And that's because it just makes it easier to edit your code. If you need to add a second statement to your body, you're already set up to do that because you've already included the curly brackets. It also reminds you to consistently indent the body of your loops and also your decision statements. And in good news, your IDE like IntelliJ will do most of that work for you. You know that as soon as you type in if or while and you put your condition in and you start your curly bracket, on the next line, it automatically indents for you so that you don't have to remember to do that on your own. The next tip is about making your code easy to read for others. So sometimes people are writing a event controlled loop, but they write it using a count controlled loop syntax. So they mean to create something that maybe works like this. I want to keep going while i's less than my counter and the sum that I'm keeping track of is not equal to 100. But for whatever reason, instead of doing that compound condition, they'll write something like while i's less than count, and then they'll add an extra if statement down here that says if the sum is 100, then I want to break out of this loop, or I want to exit the program. And our recommendation is not to do that. And that's just because it makes it really confusing. We're like looking at this while loop thinking, oh, that's a count controlled situation. But then it's not really because there's this event controlled angle to it that allows us to break out of the loop in other unexpected times. And so if you have that potential where you want to control a loop with a count, but you also have an event that might break you out of the loop, just make your loop a compound conditional that reflects both of those components of your decision making process instead of nesting a break, exit, or return statement inside the body of your loop. Just makes it easier for other people to read and understand your intention for the code. Also, even though you can write a for loop using a event controlled loop condition, try to avoid that and only use the for loop for count controlled situations. That's really what it was designed for. And then finally, try not to make your count controlled for loops overly complicated. And so remember, for loops are really for count controlled situations. Typically, you increment your step size, the increment for your loop control variable, you increment it by one. Occasionally, you might want to increment it by some other value, like maybe you want to count by twos or fives or tens. And so rather than using the update step of I plus plus, you might use I equals I plus 5 to count by fives, or I equals I plus 10 to count by tens. And that's completely fine. What we're warning you against here is don't have the user control that step. Again, if the user's controlling that, you're really writing an event controlled loop. Don't do that with the for syntax. Use the while syntax instead. So again, those are our 4 tips for making your code easier to read and easier to debug, especially if you're working with a team of people. And while that's not generally the case in Computer Science 220, it's definitely the case when you're a developer out in the real world. And so it's good to get into these habits so that they're just second nature as you're writing your code.